IRM Media. It's time for Have No Sphere. Walt here. The crew is here. We're down a couple. Unfortunately, Cammie is sick, and Josh has not made it home from work yet. Shout out. We love you guys. But we have Adam Meakin, John Savage, Rob, Freddie, Zachary Too Nice for Rice, Zabala. And we have a special guest. And the reason we're here doing this special pre-record for Christmas, Merry Christmas, Feliz Navidad, whatever you want to hear, whatever you want to say. But we are approaching the Christmas season. And for a little special present, we have Rob Durham, pilot, gyroscope expert extraordinaire, he of rigidity in space. Rob Durham, welcome to the show. We're so glad to have you here, my friend.
Hi, everyone. Thanks for having me. It's great to be here again.
Evening,
It's
Rob.
been a minute.
Afternoon.
Evening, all.
Happy Christmas.
Yeah, thank you.
Yeah, welcome back, Rob. It's been a long time. We were just about to talk about it before, but waited until we got live. When was the last time we spoke to you? Walt was saying it was around about the conference when Adam hijacked you or ambushed you at the conference. Wasn't that the last time?
Yeah.
When was that?
Yeah, it was slightly after that or before it. I can't remember.
A little bit after that, I'm pretty sure. And then I think you actually came on to the Ironworks with us on TFR for a morning show even. And I could be conflating private off the air meetings as well. So, but we appreciate you coming hang out again for sure.
Yeah, I don't think I did that, but thanks anyway.
It's quite hard to keep track of what
It is. We do
goes
two
on and what
shows
doesn't.
3 times a week. So yeah, it's a little crazy knowing what we do. And then we have the behind the scene meetings with you as well. So, and we appreciate those. So yeah, it's great to have you back. Well, what are you doing? What's going on these days with you, my friend?
Yeah, just working a lot. You know, bringing my daughters up, and doing some flat earth stuff in between. Messing with gyros, messing with microwave antennas, you know.
Normal
So for
stuff.
the people,
Just
Rob,
message, is it?
Rob, the people who probably may be listening and don't know much about you, well, when I got into flat Earth, you were doing a few videos. So, how far back did you start working out about the gyro and our flat Earth?
It was quite early on. I mean, I've been in the flat Earth, you know, since really the beginning, 2016, really, I think it was.
Yeah.
And I think it
At
may have been
least.
late 2016 to start doing the gyro experiments. Well, sorry, not experiments, the gyro demonstrations. Have to be careful what we say these days.
Yeah, you've been keeping up with it.
Well picked up there, have you? Did you?
Yeah, because I remember you put out your gyroscope video. I think it was your first one, about a week before I put my gyroscope video out, and I was just some people would be pissed off at that, but I was chuffed that you were the vanguard ahead of me, so you could take all the stray arrows and stuff. Do you still get comments on those like I'm getting on my videos?
Do you know what? I've been through all my videos and disabled all the comments.
That's right, you did, because I was going to do exactly the same, because I'm still getting retarded. I shouldn't call them retarded, but
it's like somebody coming along and graffitiing your garden wall.
Yeah. There's more
I just don't want it. I just don't need
crap
it.
up there than there is good comments. I mean, there's been some fantastic comments on it, and it is a shame to get rid of them, but I think it would carry more weight when you see, sod off with your comments. But I don't know. Some people like that, they don't like that. But I think you're wise disabling them. I'd do the same.
Hey, Rob, did you
Well,
see
Rob,
someone come up with that? Did you see someone come up with the gyro and was talking about the flat Earth and the gyro, or did you have a moment where you went, "Hang on a minute, that the gyro that's sort of a bit of a proof," or was that someone else's idea that you started doing a few experiments on?
It's a bit hazy to remember what happened back then, but I think I saw the 1950s Navy training video. Somebody had posted that about the gyroscope and the rigidity in space aspect. And being a helicopter pilot, I had a bit of a dealing with gyroscopes. You know, I know how they worked just from what I'd learned in ground school and from actually working them. So I thought, you know, I bought this. I searched for what gyros were available at the time, and the super precision gyro was, you know, it was just happened to be out there, and I bought it, and you know, just started messing around with it, and realized that what they say is supposed to happen with the gyro doesn't actually happen with the gyro.
That's exactly
So,
what
yeah,
I
that's
thought.
pretty
I'd
much
get
how
one
it
of
got
them.
started for me.
I thought I'd just film it, I'd leave it, and the whole world would realise that the Earth was flat and stationary. That's
I think we
what
all
I thought.
thought that with our first couple of videos on
Yeah.
YouTube, for sure.
Yeah, absolutely.
And what makes a precision gyro? What is there? Yeah, it's hard to put that into a question. But what makes a precision gyro? If you know what I mean.
Wow.
The revolutions of how much it spins, or
it's hard to say because some people still call them toys. I don't know if you've seen the recent Rick Zimmerman video.
Yeah.
70 Days Truth Seeker, but he was a good friend of mine, to be fair, and you know he referenced my work a lot with the super precision gyro, but just lately he's sort of had a change of heart and he's decided to start calling them toys. But to distinguish between toys and a proper gyro, I mean, the super precision gyro, it spins at, what is it, 12,000 RPM, and it's got really low friction bearings. It's in a, you know, it's machine made, CNC made.
I only ask that because on, you know, you watch a video like John's video, and then all the ballers come in there and they bag out how good the gyro is, and you know, that gyro wouldn't pick up anything. You know, it's not good enough. So what I'm asking is what's the difference between, say, John's gyros that he was and a precision, if John's wasn't a precision in the definition? Yeah, that's sort of what I'm asking.
Well, they actually call it, the manufacturers themselves call it the super precision gyro. John's got the same one as I've got, and that I did all the tests with. And I think a lot of flat earthers have bought that particular gyro.
I mean, it's sorry, carry on, John. No. Well, I was just going to say it's a 12,000 RPM precision-made piece of equipment. They show the tolerances and everything on their website. They go into quite a lot of detail on it, and like you say, the super low friction bearings on it. None of this, of which this Folcol would have had available to him, not even bearings. So to call it a toy is, in my view, a bit of a cheap jibe.
I'd agree with you, John, because...
Well, why is it called a toy?
Yeah.
Is it because of the size?
It's because it was sold as an executive toy, isn't it? And that's just... It's an odd thing. A toy, by definition, doesn't mean crap quality, does it? It means it's for amusement purposes.
Which a gyroscope generally is for most people, because they've no idea what the hell it does or what the hell it shows or anything else. But in comparison, Rob, what would you say what makes up the gyroscope in your gyrocompass? What makes that different to the super precision gyro?
Well, in my opinion, nothing really. The actual gyroscope itself, forgetting the gyro compass part of it, the spinning flywheel, it's actually the one in this gyro compass is actually smaller in diameter than the super precision gyro.
It's
you can't actually see it.
You can't play with the one in the gyro compass. That's why it's classified as a toy, because you can play with it. But as you say, actually, Rob, its accuracy is probably the same. Its spin rates is the same. I
think it spins faster,
better, but you just can't play with it. That's the only thing. And more importantly, as you say, it's actually bigger than the one in your gyro compass, so it should be less affected. And again, that demonstrates if it's significant. If the one in your gyro compass is large enough for its purposes,
well, I think a lot of a lot of people in the flat earth, Adam with his Legos, Zach with all of his toys, Cammy, miroscoping. Rob, don't I remember one of your first videos being you with the balloon and the string showing how rockets don't work in space and all this kind of stuff. Toys really can I mean, it's almost like hidden in plain sight sometimes, what it shows and what you can show with it.
Yeah, absolutely. And just going back to the gyro, I mean, you obviously saw Stefan's homemade gyro. So that was, I mean, after I watched the whole build process of that sort of take shape. We had a lot of discussions on the design of it, and one of the things we were going for was to get the flywheel as large as we could, and was actually in touch with the manufacturer who would make us a gyroscope. They were an engineering company in Holland, and they offered to make us anything we wanted as long as we provided the materials.
Oh wow!
So we was busy designing, was thinking of what materials we should make the flywheel out of. We was thinking of making the rim of the gyroscope heavier than the actual central part of the gyro. So we'd have a thin section in the middle, and then like a heavier section around the outside, kind of like a bike wheel, with the tire around the outside, and was toying with what materials to use, aluminium maybe in the middle, and then steel or brass around the edge. But the key was we was going for size, for diameter. But after seeing this gyro compass and the size of the gyroscope, the flywheel in that, it's made me think, maybe you actually don't need a massive flywheel.
Yeah.
Maybe just if you get it going fast enough, then the gyroscopic effects.
What is the RPM on the gyro compass? Do you know?
I can't find that.
Interesting. Okay.
Yeah, it's one of the things I can't find for this particular one. The manual, I've got the manual downloaded, and I've been through it from, page cover to cover.
Yeah.
And it doesn't say anywhere in there what the RPM is.
Does it give a parts list or anything like what sort of ball bearings it's using? But
no, it doesn't.
Interesting. I wonder if there's a service manual for it or something. That would be interesting. But either way, it's the size of a gobstopper, isn't it? It's smaller than a golf ball. Do you actually know what shape it is? Is it a disc? Is it a ball? Because a lot of them are just simply balls.
You can't actually see the flywheel itself. It's in a case, but if I were to guess by the shape of the case, it would be like a disc, just like the Super Precision gyro. It doesn't look ball shaped.
Gotcha. But yeah, it is very small, and it's got unbelievable amounts of kit strapped to it as well, isn't it? Weights, bubble levels, which interestingly you said doesn't find its level throughout the whole sort of process. I mean, what is the point of the bubble level being in there if it's not to show or at least calibrate it to be level at some point?
Isn't it a type of dampener? They call it a dampener. I'm gonna have to share that with you, Rob. I have a U.S. Navy something or other, and it talks about the gyro compass in great detail, how it works and all this kind of stuff. I'll drop it in chat.
Do you mean the actual spirit level is a dampener?
Yeah, there's 4 of them. There's one on the north side and one on the south, or 2 on the north side and 2 on the south side, and they're connected. Both of the liquid things are connected by a thinner tube throughout the middle. And it's supposed to have something to do with, it takes time for the liquid to go from one side to the other because the tube is so narrow, and that helps dampen out the weight or something like that. So it doesn't oscillate once it finds north. It sets on north.
That makes a lot of sense, and especially if they're linked, then they can be measured as well, and that could be going on in the PCB electricery that is attached to the side of the gyro compass. I was interested to ask you about that data dump and whether you thought if that data dump was analysed by certain people with a flat plane mentality, it would show up a bit of a clanger or a huge clue as to how the thing works and how it's. I mean, do you understand how it works? There's about a million questions in there, wasn't there? Sorry. I'll stop with that. Do you think the people who designed it and made it and programmed it know what they're doing, or what?
It's hard to say. It's baffling to me how it works. Somebody with the mindset that this thing is detecting the rotation of the Earth, and that is how it is finding its north. I mean, they're probably happy in their knowledge that that's how it's doing, and everything's hunky dory. But when you sort of analyze it a bit closer, you actually think about it, and the fact that it spins anti-clockwise as well as clockwise in the northern hemisphere. Things just don't start adding up.
When you say it spins clockwise and anti-clockwise, do you mean the dial that you're looking at?
The actual compass itself, yeah, the whole unit. When I had it opened up, the case.
Yeah.
Yeah. So the unit, the gyro sort of gimbal itself, and the compass card on the top.
Got ya.
In the northern hemisphere, obviously, with the Earth spinning west to east, it should, if it's remaining rigid in space and that's how it's working, it should always go clockwise.
I get you. I see what you mean. Yeah. And anyone who hasn't seen your latest video should go along to your YouTube channel, which is just Rob Durham, isn't it?
Yeah.
And
I can just interrupt there, John. I'm just sharing it for broadcast as well. I'm showing you guys Rob's video, which is the one we're all talking about. So if you want to refer to it on screen, it is in time.
I saw that. That's
Adam,
brilliant.
if you want to scrub to the end, sort of the last 3 quarters.
Yeah.
And I'll make sure we put that in the show description for Friday as well, the link to the video.
Great
Anything.
idea. Wow, we're so organised.
Right?
And on that, welcome to Josh.
Welcome to Josh.
Hey, cuz.
We had to start without you. We were far too organised.
I got home as fast as I could.
Far too organized for the rare once, right?
In 20 minutes, I managed to get home, get up there, get salmon made. Well, get salmon started, get asparagus started, get rice started, let the dogs out, say hello to my son, say hello to my mom, get my coffee, and get downstairs. So all in all, I think I've done rather well.
Are you currently in a sandstorm, or what's going on with your camera right now? There's all kind of like weird light thing and weird particles flying behind you. What's going on with your lighting?
I don't know what weird particles you're seeing.
I'm seeing a strange flashy thing on your green shag pile.
Oh, that's probably what that is. Yeah. I just need a little better lighting there.
But anyway, welcome, Josh. Better late than never. And sounds like you've been busy. I'm sure I had a question in there somewhere, but obviously not. Anyway, back to the gyro compass. What have you got?
Josh.
Shall we catch you up, Josh? We're just having a. Well, you probably just heard. We're just describing the non-toyness of the super precision gyroscope, even though it's a toy, or described as such. But actually, it's weight. And I was looking at it there, Rob. Actually, it's very similar to what you tried to replicate, isn't it, in terms of the shallow pan. And then we were just trying to guess of the many bits he's took apart on the gyro compass. I don't think he's got inside the shell, so we're just kind of guessing, but we're assuming it's a similar size and shape. So I think that's you up to date, pal.
And probably the most important bit of information is that we're live on our Christmas show.
Are we live?
In the
Awesome.
past. Ghost of Christmas past, we are.
Awesome. Sweet. Good to know.
I thought that would be good to know.
You got any Christmas buttons, Josh?
Not preloaded.
Damn.
I do have some. Yeah, if you give me a few minutes, I'll totally get some up there.
Yeah, I think we've got time, haven't we?
Well, what are the other questions? Where do we stepped off the gyro compass already?
Well, it's only to welcome Josh. So
Yeah,
what
I
I'll
know,
do is I'll put it back in terms of on the transmission, and I think we've got Rob with the gyro compass. Is that about where you wanted it, Rob? Somewhere 3/4, somewhere there where you're showing the precision one?
Can't actually see what you're looking at there, Adam. I can only see a still shot of it.
Yeah, the screen hasn't changed for at least a minute.
Yeah, we're still seeing it way back at the beginning.
But when we scrub to the 3/4, what we're going to see, Rob?
It's basically the movement of the gyro compass itself during a test, a bit further past this.
You can see it now, yeah?
Yeah, I can see it now, yeah.
It's where you, yeah, we can, yeah. It's where you were scrubbing backwards and forwards as well, wasn't it? Showing it going clockwise or anti-clockwise.
Yeah, I did. Yeah, keep going past this. It's until
Past
you see
the
the gyro.
I'm happy to go well past the globe, Rob.
Yeah, here.
Yeah.
So talk us through it, yeah.
I'll talk you through it, yeah. So this is the whole unit is aligned north at the minute, and I had the gyro itself aligned north to start with. So this is test number 1, and it sort of oscillated back and forth a few minutes. Took 39 minutes, but found north again. Then I take the case off and manually rotate it round to which way is it going? So now the gyro is, the axis is actually west of north, and I set it going, and as you'll see, that's just setting the latitude that I'm in, just proving what latitude I'm at, and speed. You have to set the speed in at being 0. But then once it goes, you can see it now rotating clockwise to find north.
Yep. Overshoot.
And then it goes past, it's just gone past north slightly, and then it's coming back to settle on north.
And that was sped up, wasn't it?
Yeah,
48 minutes.
48 minutes, yeah.
And that's
Now,
baffling too.
when you did your super precision gyroscope hanging by thread, and it was oscillating back and forth, was that in a northward position?
I wasn't taking note of that at the time. I could probably think back to how it was.
Great question.
We'll probably match it up by your tiles, Rob.
Yeah, I was going to say. I said Rob will know, or he'll be able to work it out because it was done in his kitchen or whatever. So.
Yeah. But can you see it's going counterclockwise now? I had it on south initially.
Mm-hmm.
I've got a question on that, Rob, because I remember when you first said, in terms of the direction, is it the shortest route to north?
Yes.
Besides its route. Yeah, that was brief then.
In a word.
Yes.
I heard enough of your question.
That's a strange thing. It kind of behaves like a magnetic compass. So it's now east of north.
That's what I was thinking, because it overshoots and it comes back. If you spin around with a magnetic compass in your hand and suddenly point north, it is going to overshoot. It's got momentum.
Now, does that points to true north? How close is that to magnetic north? Have you ever put a compass up next to it to see if they're pointing in the same, like the exact same direction?
Yeah, so at my location, the magnetic declination is only 0.5 degree. So it would be very difficult to see the difference between the two. However, if it was there's some places in the States, I think, that's like 14 degrees magnetic declination. So you'd definitely be able to see a difference there. But it's virtually magnetic north and true north at my location are the same.
And do you think
I was reading somewhere? Oh, sorry, John.
No, you go.
I was just saying, I was reading somewhere that even the gyro compass, I thought it was in the naval document, but I was having trouble finding it. I've been reading so much on these lately. But it said even near the poles that they have trouble finding true north because the Earth is rotating so slowly underneath them that they can't find true north.
And that doesn't make sense, because the Earth is still rotating at 15 degrees per hour beneath them, wherever they are. Sorry.
Yeah, the manual says to this one that it's no good for latitudes 80 degrees north or south. So it says to put it into manual mode if your latitude's north or south of 80 degrees.
That's interesting, isn't it, Zach?
Yeah, it is.
But do you see what I'm saying as well? Even if you stood on the North Pole, you're still rotating at 15 degrees per hour.
Yeah, well, that brings into question the whole latitude input of these units as well.
Exactly. Why do you need to put it should be telling you what latitude it's at.
Yeah.
Not you telling it what latitude. And I take it won't work unless you put a latitude in there, whether true or untrue.
You forced it. The unit is forced to have a latitude in it, and even the older ones had latitude compensation devices on there. So it's not like it's a new thing. They've all got them, but it just makes no sense why you would need to do that.
Yeah, that's what I'm
I've
saying.
tried putting a false latitude in there already, and it was like 5 degrees difference from true north.
Okay, so it certainly does rely on the latitude that you input. What about the speed? Does it need, because I saw the button, the speed, does it need a speed input in order to output, if you get what I mean?
Yeah. I mean, the manual describes all the errors that you can have on these. There's latitude error and speed error. So it says that you must have your speed input into there.
What if you're stagnant? What if you're just sitting still?
Yeah.
Can you put 0 as a speed?
Yeah, those tests I just showed earlier, I was showing the latitude first, and then I hit the speed button, and you can see it says speed 0.
But I mean, these are designed to go on ships, aren't they, which have hugely varied speed, I would imagine. I don't know for sure, but I would imagine, it's the speed in knots.
Yeah, it is, but it's not like you have to keep entering your speed in there manually, because it will take a GPS unit. You can plug a GPS unit into it, and it will keep the latitude and the speed updated automatically.
But if you didn't have the GPS unit, you'd have to do it physically. So at 1 minute you're going with the wind at 40 knots, and the next minute you're going, you're tacking or whatever at tacking. You know what I mean. You're going at 30 knots against the. You'd have to put that in manually if you didn't have the GPS module plugged into it, right?
Yeah, and if you think about it, that's what they must have had to have done, years ago, before GPS was, sort of wide scale.
Yeah. So again, shouldn't this thing be able to tell you what latitude you're on and tell you what speed you're doing? If it's measuring a supposed spin of the Earth, those are the sort of calculations this sort of thing could do, surely?
You would have thought.
That's what I love about you, Rob. You're very conservative. And I don't mean in a political way. Yes.
Do you think magnetism, the Earth's magnetic field, might have anything to do with it?
I have thought about it.
Kind of a vague question.
Yeah, I mean, it could. The fact that it would point to true north with a declination other than 0 or half a degree, like it is at my location. The fact that it still points at true north and not magnetic north is makes me think it's probably not magnetic.
Did they need to put magnetic declination in back in the day? Before it was all computerized?
I don't know, actually. I don't know how long they've known about magnetic declination.
Yeah, nor I.
Or whether it's even a thing, I would hazard to proffer. I don't know.
I would guess it is a thing, because obviously maps are reprinted quite regularly, especially for navigational purposes, and each map has the declination printed on the map and a line drawn across it, depending on the year it is, and they recommend that every few years you update your maps with the new magnetic declination on there, and they do actually set the compasses, to the declination reading. So
that makes a lot of sense. Yeah, I'll retract What about that big lump of mass on the back that we're looking at? Could that
Before we
be
get on to that, John, can I
ferrous
just,
metal?
on that topic,
Just two
ask you a
words.
quick-
I only had 2 words.
Well, but it was what you guys were saying there
Go on.
about
Go on.
yearly updating and stuff. And I just wondered whether that had, if you think of it in terms of the pole star having a slight wobble, whether it had it had something to do with the overall shift of a magnetic field, and that's why they're suggesting not daily updates but actually yearly updates, because there is going to be a slight like there are lots of rotations but an overall slight change as well.
That's a good point. Because you can see a slight rotation of Polaris on a time lapse. So you can imagine if the ether or whatever is like a spinning top above us, but Polaris is slightly off center, then yes, every year would change, would shift in a cycle
And
sort of thing.
truly, we could on Ironworks do a story every day about the shifting magnetic pole, because in our feed that we look at all these space stories, I see a story about it every day, a different news source telling us how it's creeping closer to Siberia by the minute.
And all I'm meaning though, if you think about the way a magnetic field fans out, whilst there may be a very minute optical difference in the North Star at the center of that toroid, once those fields spread out, that minute difference is magnified, which may give significant reason to there is a slight variation over that time, that as you get further away from the center, it increases the variance.
And does it lend credence to, places in the south, so-called pole, that have declinations of nearly 180 degrees sometimes?
If you follow the shape of a toroid, it does. Don't
Exactly, yeah. That's what I was thinking. Curls back in on itself, doesn't it? Anyway, my original question was that big lump of metal, is that ferrous metal? Is it magnetic? Is it, what is it, steel, iron, whatever?
I think it's iron.
Yes, my fingers were crossed.
I'm just wondering why it needs to be so big, and it's lopsided as well. It's not a symmetrical object. Could that be what's finding north, as in a magnetic compass?
It's possible. Like I say, though, it's different. North is different. If I went to America, for instance, and I went to a location where there's 14 degrees of magnetic declination, the direction this points in comparison to a magnet would be 14 degrees difference. So,
oh, that's interesting.
What they're saying that this is for, this is actually something that Zach mentioned earlier. They call this weight a damper, and it's obviously top heavy, so it's meant to sort of dampen out the oscillations that the gyroscope makes and use it to settle on north along with them weights on the bottom.
Got you, like pendulous vanes, or the same, similar.
Yes. So
the dreaded pendulous vanes.
It could be.
And what?
I'm open to any idea at the minute. I've absolutely no clue why it is seeking true north. The only sort of what's the word?
Clue.
Clue, yeah. The only clue I can think of is that. Sorry. Just give me a second.
No worries.
Go
go ahead, Zach.
I was thinking maybe it's measuring not like the magnet, like a magnet does north, because I know you have to line it up a certain way, the wheel, to start it. So what if it's measuring?
What, the gyrocompass you're talking about?
Yeah.
You got to line it up
east to west or something. There's.
Oh right, really? Didn't know that.
And
What
and
if
then
you're
you
on a boat,
started-
though? Does the
It
maybe
might
it
do
moves
that all by
independently or
itself,
something?
yeah.
I don't know. That's very strange.
But it starts in a certain way, and then you put the weight on there, dampens it out, and starts doing it, and it starts. I don't know.
One of
Can
the other
almost
big
see
mysteries
it.
is how does it know which is north and which is south?
Yeah, exactly.
That's possibly
I'm
one of the biggest sort of wrenches in the gears, isn't it? Can you elaborate on that one? Because how does it not know which is north and which is south?
Well, presumably it's trying to find the rotation center, I guess, the axis of the Earth. So you would have thought that it would be like a 50-50 chance as to whether it finds north or whether it finds south. That's what I would think. But as we've been talking tonight, it's just dawned on me that I should probably look which side this big heavy metal piece is on, whether this is the north side or the south side. I can't think off the top of my head.
I imagine it's the south side, but I couldn't elaborate on why. Because everything's telling me it should be the north side, but I don't know. Maybe I think I know the layout of your house. Crickets. We got Rob back on.
Can I just, Rob, just to come back to it tracing true north, that would just seem sensible to me. If you're going to put all that software in there, you want something that gives you a easy readout for you to put onto your maps, and your maps are going to want to be using true north, and then you can use it anywhere, can't you? Whereas you've got all sorts of alterations you need to consider, i.e. latitudes and the likes, and altitudes based on where you are. So if it can then, and maybe that's why it keeps asking for additional data, so it can compensate for variance of the field, so that it can just then give the user a straightforward bearing to true north, which is easy to navigate from, just the center of the map.
Yeah, I mean they're said to be the primary navigational tool in the boat, in the vessel. The magnetic compass is secondary to the gyro compass.
Yeah. So if you were like, I don't know, somewhere near America, and it's just tracking magnetic north for you, then you've got all sorts of secondary considerations you've got to make, haven't you, before you can easily just locate where you are.
Yeah.
Whereas if it's doing all that for you, but it is requiring the input of longitude, latitudes frequently, maybe the purpose is to calculate for deviation. So it's just a user facility reason. There's nothing nefarious there. It's just simply so that the data it gives you is quickly plottable from an AZ map sort of thing.
Yeah, absolutely.
Well, I'll tell you what, Rob. I did quite extensive research into the difference between a gyrocompass and, correct me if I'm wrong, bearing indicator or heading indicator in a plane or a helicopter or whatever.
Yeah, they're worlds apart. The heading indicator, I tested one of them in a previous video. I've got one of them as well.
Fantastic video. 51 minutes or something. It's fantastic.
Is that in the car? Is that when you strap it in the car?
Yeah.
That was brilliant. That's class, isn't it?
Yeah. I don't know why I did that. It was just seemed cool at the time.
It's still cool now, Rob.
It is, and you spun it up with air as well. It was an air powered one, a vacuum powered one, wasn't it?
Yeah, I had a compressor on the back seat.
Yeah, and even when you'd been driving for 20 minutes or something, this thing was barely turning, but still registering its movements.
Yeah, exactly. Yeah.
So
So
what's
what
the
did the
difference?
Globers? What did the Globers say? Sorry, John. What did the Globers say about that one in comments? You had comments from the start with that one on the YouTube video. Did
Yeah,
you get bagged out for some reason on that one?
yeah, they were saying things like I put the air pressure that I put through it was too much. I'll have damaged it. It's not working properly. Blah blah blah. Yeah,
The F's the ball. The F's the ball.
Yeah, it's
Yeah.
always something, isn't it? It's always something. But yeah, I don't think we can ever beat their comments like that, can we? Can we ever beat them?
You just switch them off, like I do.
Great answer. These religious types, you just can't get over them. And let's not beat around the bush. The spinning ball heliocentric model is a religion. I'm sorry, it's pure belief. And what you're facing here is pure. No, I'm not going to say it. Science. What's the word? Test it. Hashtag test it. Sort it. No, I think it's brilliant.
To think people are standing in funny directions all over the globe, it's just crazy. You've got to be stupid to believe that. I'm sorry.
Yeah, and I will quite openly admit, when I flew to Australia, I readily thought to myself, wow, I'm standing upside down. How crazy was that? But here's an idea. What if you had an experienced electrical engineer or someone who knows about PCBs and everything that can identify each and every component on that extensive board that is surrounding your gyrocompass, and could just tell you, because you've got thick wires on there, you've got numerous thin wires on there. They're thick for a reason. They go into they look like sweets to me, but these people know what they do and everything about them. What their ohms capacity is and how they perform. I mean, that's got to be a way forward, isn't it? I mean, a proper tear down of what the circuit boards are on this thing.
Yeah, I mean, you can actually. There are connections on there that you can make and get the readings off. There's a 60-way test connector on there as well.
Yes.
I don't personally know much about that sort of thing myself, but
I was going to ask you about that though. You can actually plug this thing into what did we used to call it? It was like
there's an RS-232 connection.
RS-232. Thank
you. Do you remember the song?
RS-232.
Isn't there a spitting image song about that? It's an RS-232 interface lead.
No way.
It is Christmas, so that's.
No, I wouldn't be surprised.
I remember the chicken song. That's about it.
I do know that all the way through.
I remember the German
South
song.
African one.
Yeah.
I remember the German one.
South African.
And that's not bloody surprising.
Man. I'm not carrying on there, Ron.
No.
And
gets a bit unpolitically correct after that.
Oh wow.
And just to say that it is Christmas on our show here, and this is our Christmas present to you. Of course, it's not. It's a couple of days before, and we're all lying. But I can't lie.
Ruiner.
I can't lie.
Last year, because I thought you were a burglar.
And when I said crickets earlier, was that actually not crickets? Was that jingle bells or something? And I thought that was crickets.
That's with crickets.
Crickets would have been better actually, because the conversation had died at that point. But there you go. There you
Look, Charlie, let's face it. We all know that Christmas is a big commercial racket. It's run by a big Eastern syndicate, you know.
Say truth from children.
Wow. That wasn't the
track.
real Charlie Brown, was it?
Yes, that was the real Charlie Brown.
We are hurtling for the edge, Adam.
Yeah.
Bring us back. Bring us back, Rob.
Okay. Where were we?
I want to know if anyone is capable of plugging a plug into this gyrocompass and actually venting the output onto a computer program and analysing it. That's what I'd like to know.
I
plugging it
assume,
in.
Rob, it's got what you're getting from the RS-232 is it would give you real time tracking data. I assume that's what it's purporting to be.
Yeah, I was hoping that we'd be able to take the sort of the azimuth, what forces are being acted on what, and what accelerometers are acting at any particular moment. We can sort of work out then what movements are happening.
Yeah,
See what I
the
mean?
X, Y, and Z.
And it's getting that data out onto a format that's you can sort of log. That's the bit I'm not really sure about. I think you have to put it into a CSV file, and then you can import it into Excel.
But you're a CAD engineer. This is like chicken feed, surely.
Let me just ask a Dimbo question. So the purpose and the inference you would draw from that is obviously it's sat on your kitchen worktop. Is there going to be any change data or manipulation movement that is generated when it's static? Is that what
you're after a hypothesis, aren't you?
I wouldn't go so far, sir.
I don't know. Maybe a
hypothesis.
hypothesis.
Asking for analysis of data, it wouldn't be.
Well, maybe we should start at the hypothesis. What? Because unless you've got a hypothesis, there's no. You're sort of walking blind, aren't you?
The result is it's man-made. You
Yeah.
can't science it.
It's
but
not
you
a natural
can-
phenomenon.
You can draw inference from the
Okay.
results. So
Or what about an inference hypothesis then? Or an inference theory? If we did this.
The point of my question would be that if you're going to try and apply some inference, you would say that if there is rotation, you would expect some realignment or adjustment or wobble, maybe more so in this case, due to changing the magnetic field due to rotation, if there was any.
Well, I'd say like a comparison with and Zach, if you're around with the fog gyro, when you had it at a certain altitude and then you brought it to a higher altitude, you formed a theory that if the Earth, if it's measuring Earth spin, then it's going to keep the same rotational rate between the
It should
two.
always be equal.
Yeah, latitudes,
As long as you're on the same latitude. Yeah.
And that's not what you found.
No.
The fog gyro matches Zach, doesn't it? A toroidal shape. As you increase in altitude, you get an increase in rate.
Decrease. Decrease.
I'm not really sure.
What was an increase in rate as it went up?
I'd have to go back.
Well, I thought it was like the proverbial hurricane that was spinning slowly at the summit and spinning like a mofo at the eye, as it were.
And
that's how the magnetic field does.
We're off onto optical gyro. So just to...
Yes, and that should be highlighted as an absolutely separate subject to a mechanical gyro. But
just to bring us back on that, John, right? The mechanical gyro, right? This gyro compass. Maybe Rob.
I wouldn't call this a mechanical gyro.
Well, no. Maybe Rob could. Fundamentally, Rob, we know what a gyro does. We know what a compass does, right? What would be the fundamental purpose of putting the two together? Like if I put wheels and a motor together, I can make a car. Yeah. If I put a gyroscope and a compass together, what's my initial concept? What's the gyro doing for the compass? What could the compass be doing for the gyro?
Well, it's improved upon the magnetic compass in the fact that it points true north. So I guess that's its main benefit. But the other way around, what's the compass doing for the gyro? I don't know.
I mean, like you said, the magnetic compass is a slave to this, which okay.
I mean, this doesn't suffer the problems of if you put a magnetic compass near some steel, it deflects.
Right.
And you can't keep it steady. Even in my kitchen, when I'm around anything, even if I put my magnetic compass on my worktop, there's like bits of metal in my drawer runners and things that sort of deflect the needle, whereas these things stay sort of bang on because of the gyroscope. They don't get affected by any metal, which is another reason why I'm thinking it's not a magnetic phenomenon.
Have you got a bit of metal that is bigger than that big chunk of metal in there that you could put around it? And even better, have you got like one of those 5 kilogram neodymium magnets you could bring near it and see what that does to it? Do you think if you had a magnet the size of a Christmas cake brought to the side of that gyro compass, do you think it would have any effect on it, and if so, what?
Well, probably only in the fact that the gimbal casing would be attracted to the magnet somehow, I guess. Do you see what I mean? I guess you would hold it.
Yeah, is the gimbal casing, is that not aluminium, or I don't know what the materials?
No, that's steel.
Right, so there's a lot of ferrous stuff in there, is there?
Yeah.
Okay.
I mean, I think that big damper weight is ferrous.
Yeah, you were saying, yeah. So that would rule out the sort of magnetic influence on it.
Well, no, what I'm saying is if you put a magnet next to it, it's gonna attract it to the magnet, isn't it?
Okay, yep, I've got you. So
you see what I mean?
It might be the magnetic attraction of whatever the North Pole is. It might still be that.
What I have thought about doing, and it's going to be pretty difficult, but it's putting it in a zero Gauss chamber, to block out the magnetic field.
Well, yeah.
Magnetic field, but they're very expensive, and to have one the size that would fit that unit in would be
that's a big chamber.
Prohibitive.
Yeah, you'd need a university or something like that.
Speaking of which, I am actually working on a project for a university at the minute. We're building them a test facility to test high voltage electrical systems, such as motors for air, electrical motors for airline planes, because obviously they're doing away with fossil fuels, aren't they now? So the research is heavily into electric motors for planes, and this facility that I'm involved with helping to build is to test that sort of thing. And within that facility, they've got what they call a magnetics room, and they've got a EMC room, which is an electromagnetically shielded room.
Ooh.
So I'm thinking of sweet talking the contact I've got at the university to ask him when it's built and finished if he'd let me just test it in there. I mean, I don't think anything's I think it'll still behave as it does, because it's essentially just a Faraday cage, this room. Right. Which really only blocks electromagnetic signals. So, but it's worth trying.
Absolutely, yeah. I mean, everything's a good test, isn't it? I mean, at altitude as well. Take it up Ben Nevis and see what it does. Yeah, it's difficult to know what to test, but every single test takes an awful lot of organisation and, like you said, backslapping and handshaking.
Yeah, it's interesting as well that they don't use these gyro compasses in aeroplanes.
That's what I was wondering earlier. I mean,
can you
see
in
why?
Light aircraft because of the weight of them, but in commercial aircraft, and I think it's to do with the speed that the aircraft travel. I don't know if it'd be able to handle the sort of speeds in a boat. They're quite slow moving, aren't they?
Well, have you tried putting an equivalent air travel speed in knots into the gyro compass? Like, what's the maximum speed? It's usually 499 or something, isn't it? So
Yeah, I've not actually messed around with the speed setting yet, but
Ah.
we do intend to put false latitude inputs into it, and like 60 degrees north, 80 degrees north, 40 degrees north, 20, and then go 20 south, 40 south, 60 south, and just log what north heading it finds with the false latitudes. Maybe there's some sort of pattern or something we can get from that. Or
do you know anyone that's capable of venting off the data from that it wasn't just a 232 port, there was like a 19 pin massive ribbon,
60 pin
60 pin
60 pin, yeah.
Do you know anyone that's capable of venting that off into a PC somewhere or for analysis?
No, well, I was gonna give it a go in the first instance. I mean, I know that the manual tells you what all the pins are. It's just getting the connection
Bloody
to
hell,
get into
Rob.
the laptop and trying to interpret the data so that comes out of it somehow.
So I think I'm talking to the guy that has an idea of how to do this. Bloody hell, Rob. That's 60 pin. Where'd you even start? What does it plug into on a laptop or something? Or
well, we'd have to adapt some sort of RS-232 cable to USB, I guess.
Right.
Because my laptop hasn't got an RS-232 port.
I'd be surprised
But you
if
can get
anything
converters to USB.
under 20 years old has an RS-232, but
yeah,
actually I do. I've got a EEE PC that's got an RS-232 on it, if you need it. Interesting. So you're still playing around with this?
Yeah, there's still more a lot to do. I mean, we're trying to think of some tests we can do with it with it actually moving, because it's, I don't know if I explained, it's got two modes on it. The first mode is the north seeking, and that takes between 24 minutes and 90 minutes to complete, depending on what the initial alignment of the gyro was when you first started it up. But then it's got its north keeping mode. When the north seeking is complete, a green light comes on and it says ready, and from then on you can use it as a navigational instrument. So it can then be moved around. Whilst it's doing its north seeking process, you need to keep it as still as possible. So if you was in a boat, you'd obviously have to be moored up and secure for it to find north, which is another thing I'm not. If there was a power failure, these things have to start again from scratch. So if you've got a power failure and you're in the middle of the ocean, and this is your primary navigational aid, how do you reset it going again if you're in the middle of a choppy ocean?
Got to take the reading from the magnetic north.
You'd have to, wouldn't you? You'd have to ditch the compass.
Well, interestingly, on planes, they suggest that is it a bearing indicator or a heading indicator?
Yeah, they call it a heading indicator.
Heading indicator. They suggest that the heading indicator needs to be sunk with the magnetic compass every 15 minutes. But they don't require that on the gyrocompass, and the only difference I could see between the two was that the gyrocompass was continually talking to the magnetic compass, whereas the bearing indicator, heading indicator, was I've forgotten what you said already, was needed to be adjusted manually. Does that ring true? Or
in the aircraft, the heading indicators in an aircraft, the general rule of thumb is that every 15 minutes they drift about 3 degrees, and they claim that this is due to the spin of the Earth. Yet, from my own experience, they don't drift clockwise as they should, and they don't drift at a constant rate either. And they don't caveat it either by telling you at your latitude it should drift this much. If you go to a different latitude, it should drift this much. They just give it a blanket 3 degrees every 15 minutes with no direction whatsoever.
Anywhere on Earth.
So, anywhere on Earth. So, what I noticed when I was flying is that they can drift either way. west or east, and it all depends on the movement of the aircraft. So if you're going straight and level, and you go straight and level for miles and miles and miles, and you've gone over 15 minutes, then it may not have moved at all. You may not have to reset it whatsoever. But if you've done some heavy maneuvers one way or the other, then chances are the friction that has been experienced on the bearings has caused it to drift, either left or right, depending on the way that you've turned, and you have to correct it. So it's just given as a blanket rule of thumb, 3 degrees every 15 minutes, and you should check it every 15 minutes with your magnetic compass.
And let me guess,
if necessary.
Let me guess, after doing said manoeuvres, you are instructed to make sure you're flying straight and level when you check it.
Yes. There's a thing called the Hazel check. You have to do it every 15 minutes. It's a while since I've flown now, but it's an acronym, Hazel, and you have to, H is the heading, obviously, and then each letter stands for something else. So yeah, you're trained and it's drummed into you. You must do your Hazel checks every 15 minutes.
Wow.
One of them being heading.
Wow, well, that's a fail-safe.
Sometimes it may not have moved at all.
Well, like you say, if you're flying straight and level, you're probably not surprised that it hasn't moved at all, as you'd expect if you were flying straight and level, regardless of what's spinning below you or anything else that's going on. If you start doing barrel turns or whatever they're called, manoeuvres, then, like you say, the friction is obviously going to play a part, precession's going to play a part, and you're going to then be instructed to fly straight and level so that your magnetic compass works nicely, and you read it off the magnetic compass and reset your heading indicator. There's no reason not to.
That's basically what I was going to ask, Rob. So you found that it was, if there was variance, the variance was probably more correlated to how you've been maneuvering than maybe. So there'd be, if you've been not checked it for 10 minutes and you've been flapping around doing all sorts of aeronautical stuff, there'd be more variance there than if you'd forgot to check it for half an hour.
Yeah, absolutely.
Yeah.
After flying straight and
so the
level.
Variance is related to.
Whereas they're claiming the variance is systemic, if that's the right word, and it's due to the Earth turning. But you're saying that it's like a blanket 3-degree correction every hour or 15 minutes or whatever you said. I can't remember. My memory's like a sieve.
I mean, even in the manuals that you read, it gives you the blanket 3 degrees every 15 minutes, and then blames it on the Earth spinning. Whereas then we're given the 15 degrees, or you times the sine of your latitude calculation. So there's a disconnect. In the one hand, we've got this calculation that shows you how much it should deviate or drift. And on the other hand, they're telling you 3 degrees every 15 minutes, no matter where you are.
I mean, that latitude calculation always cracks me up, and I always go on about how Aries, who was the astronomer royal at the time, he claimed he didn't believe that latitude calculation. He called it something derogatory, I can't remember, but I don't know.
I think what is happening is the latitude input that you have to put into the gyro compass. I think that is somehow using that calculation.
Yes, I agree. But in reality, I don't think that calculation. I just don't know. But for the astronomer royal of the time, who also called Foucault a fraud, to bring into question his mathematical equation, including the latitude thing, as some sort of fanciful mathematics, it just got that stuck in my mind, if you know what I mean.
Yeah, I've not really seen it. I think, did you post that in the FE Core chat at some point?
I did, yeah, at some point. Yeah, it's it was him, and he was talking to Mark Twain, maybe, who was the professor something or other of science at some university, some quite prestigious university. Mark Twain. As far as I know, anyway. I'm probably talking out of my arse. Can anyone, you guys have heard of this story numerous times, the amount of times I repeat myself. Can you back me up on any of it? You weren't watching me, you were just...
I don't recall this one, John.
I'll have to go find it now, won't I?
Yeah, this is news to me, John. I don't know.
Probably a meeting you and James were having.
So, Rob, what does 2020 bring for you? What's on your horizon? Are you back out on the microwave spectrum again? Because you were one of the few people who was at the location that was attempting the world record, didn't you? And you did get a connection, but you talk us through it, mate.
We thought we got a connection at one point. It wasn't a solid lock as we'd have liked, but I think in fairness we bit off more than we could chew with the distance. I think it would have worked, but our aiming process and precision wasn't the greatest. We had Sandor up one of the towers manually trying to adjust this thing. And if you imagine, I think it was over 300 kilometers, the distance between the two. If you can imagine trying to aim with microwave.
Is there any way to connect the dish to the salad?
That was my question. Is that you need a salad dish?
Explain what the salad is.
Super accurate laser aiming device. It's the FE Cores laser device that Mike constructed to aim the laser across Lake Balaton.
Oh, come on, that deserved a soundtrack. Dun, dun, dun. Sorry. He used it across...
That was pretty accurate, wasn't it, Rob? That was...
So accurate, the military were after buying it, weren't they, at one point?
There were some parties interested, yeah. He did a good job of it. It used GPS coordinates, and it just, through Mark's engineering skills, mechanical engineering skills, he was able to make this thing aim by a motor, stepper motors, I think it was.
Yeah, amazing.
So it could aim at a precise location.
Do you think a mini version of something like that is probably necessary, Rob?
I was going to say that thing was fucking huge, wasn't it?
But the accuracy it gave, and the fact that you weren't doing it, it weren't wobbly hands, or I just wonder whether that's the next step forward that gives because one time the question is, how was Sandor moving that thing? Was the cranks on it? Was it just
at first he was doing it by hand, but the place we was at was an amateur ham radio engineer's station, and he had a really, really nice setup. He had massive antennas. He had this big compound with a house in the middle that he used to just spend days up there. And I've never seen so much equipment. And he got about 8 really tall towers. He got this fire engine that was about 40 years old that he used. And Sandor actually used that to get up onto one of the towers. But the basket of it wouldn't actually get right to the top. So Sandor was he was kind of jumping from the cage of the fire engine ladder to the tower with a microwave antenna in his hand. It was pretty precarious.
Bloody hell.
So at first he was doing it by hand, but this tower, they did have an old device. It was like a Russian-built device that actually they could control it from the ground. So we attached the antenna to a pole, and the pole was able to be rotated in increments from the ground. But those increments weren't accurate enough. I think it was 1 or 2 degrees at a time, whereas we needed a sort of 0.1.
Yeah, I was going to say
degree.
1 or 2 degrees at a time. Compare that to what Mike's salad did. That was
The
on
trouble with the salad
magnitudes of
is it's too big. As it stands at the minute, it's too big, too heavy to get up there.
However, you don't necessarily need towers, though, do you? I mean, if you assumed, and let's be crazy for a minute, that the Earth is a plane, then all you've got to do is have 2 mountains that would be able to see each other, and then lay the salads on top of them with the, on the ground, on the peak of these mountains, and accurately aim them at each other, and theoretically you should easily be, without having to go up any life-threatening structures, don't you think?
Yeah, there's 2 problems with finding locations for these microwave antennas. The first is elevation over long distance, and the second is power. Getting
Yes.
power supplies.
Power.
Power.
The amount of places that we found that are like suitable, but we've got no way of powering them.
Well, you tell us what power you need, and Zach will come up with the answer. I'll guarantee it.
You want those batteries they use for the lunar missions. They'll give you enough power. They can do it from.
Yeah, they never run out, do they? The ones on Mars.
I would say go for the Voyager batteries. Those apparently never stop working.
I would say go for a generator, because I always destroy batteries, no matter what they are. I've gone through tons of them and boil them and burn them, and I'd go for a big ass generator.
If we found a suitable location, if we find a suitable location, it's getting because they're quite heavy, aren't they, generators, and getting all the fuel and the batteries. It's lugging them all up a big hill. I mean, it's not beyond the realms of possibility, but it's just
it's a mission
to get everything just right.
It's a mission.
Just in terms of this accuracy, in terms of, there's obviously when I think of sending a beam, a microwave signal, I think of it diverging, and there's is there a hot spot that you're trying to create as well, or what's the kind of variance that you've got to play with from the center point of the beam that you're trying to kind of match up? If you got a kilometer, half a kilometer, 100 meter, what kind of leeway have you got?
Well, if you think about the actual width of the beam, because we did Fresnel's own calculations to know if we were getting up high enough so that the beam didn't interfere on the ground, and the distances we're talking about, 300 kilometers, the radius of the beam was 50 meters roughly. So you've probably got 50 to 100 meters of accuracy, being as that was the radius. So the diameter is probably 100 meters. So
is that a limitation of the equipment, or is that like a industry standard?
That's if you're transmitting at a certain frequency, then that beam width is dictated by the frequency you're transmitting at.
Okay, I've got you. You're going back to. Are you a ham radio operator? Oh, you're not. Are you? No.
Me, no.
Sorry, carry on.
So that's at 300. What distance? 300
kilometers.
300 kilometers. You're trying to hit a target that's 50 meters, basically, and you've got a 50 meter bit. So that's. It kind of puts it into scale why you can be miles out. Think about just aiming a laser and you start to get to 300-400 meters. The way,
but this is
tiniest movement creates such a variance.
This also brings up the ludicrousness, if that's a word, of the your satellites on your house.
Yeah.
The satellites in the sky are meant to be 22,000 miles away. And an engineer can go up a ladder and just by hand just point these quite quickly in about 5 minutes at the dishes, 22,000 miles away. It's just
and we're talking. Well, that's interesting, Robert, because we're talking degrees of accuracy here, and the further away, the smaller the degree of accuracy you have to have, don't you? You know what I mean? So Therefore, that is clearly an indicator that whatever a bloke on a ladder with a spanner can line it up to, it can't be that far away, can it?
Not
Definitely
really.
not.
But also lends credence to the use of a salad device at either end of, because I don't see the problem there. If you know the topography of the land, you'll know that in an ideal world, i.e. flat, then this should be able to, from the top of this hill, should be able to hit the top of that hill by inclining it, 5.4 degrees or whatever. And you've got the salad there to help you. Yeah.
When is the next set planned? Have you got any next Ferraris out, Rob?
We're thinking about doing it again next year, maybe when it gets a bit warmer.
Yeah.
We don't want to do it in this weather. But I don't think we're going to go as far this time. I think we're going to go try for somewhere closer, because we don't actually need to go that far. We wanted to try and break the record. That was the purpose of it. But
I still like the
Mike's
idea of Holland to England. That was a cracking idea. Didn't you have a location on top of the White Cliffs of England?
There was at one point, yeah, but Mike couldn't find anywhere in Holland suitable with a power supply again. It was the power supply was the problem, I believe, in Holland.
What sort of power are we looking at? Sorry.
I mean, it's not a lot of power needed, but you need it for quite a long time. And if you can't get it if you're there for a day and can't get it, then
So a generator would be a viable option, or these power bank things that these tiny little power banks that can jump start at 4.2 litre diesel.
Yeah, I mean, we were spoilt last time because we had these both sides of the transmission were in one of these ham radio operators, so we had as much power as we needed.
Yeah, they're funny folk, those ham radios. Sorry, Adam. What was?
Well, I think I mentioned it with Zach a while back. I'd love to get my hands on the salad, Rob. Because I'd like to take it down to Home Pierpont. I've looked at the rowing stretch, 2 kilometres, which gives you 30 centimetres of curvature that should be there. And I just wonder if you could set rather than going for distance, because the salad is so accurate, go for accuracy over 1.5 miles, 2 kilometres. And I just wonder if we could set it up there and we could guarantee its levelness. I think if we could use a laser over that distance, we should centre point be able to demonstrate not 30 centimetres of.
That's a good idea. Accuracy over short distances. That's like what's his name, wasn't it, on the canal? Cool. Robotham. Yeah. You did that canal thing, didn't you, Rob?
Yeah, I tried to do a microwave test across it, but I don't think the microwaves were suitable, and I don't think we had proper line of sight either. There was trees and bushes and stuff in the way.
Yeah. That was a good effort, though.
Yeah, but Mike has actually done a successful microwave test. Before we went to Hungary, he did it in Holland across a lake. I think that was 40 kilometres. He already beat the record. Not the record. He already
beat the laser record.
The 4/3. The 4/3 R supposed K value limit for radio microwaves.
He already did that in the now long forgotten concave Earth stuff. That was one of the tests they did there, wasn't it? It was a microwave over a lake test as well.
Did they? That's news to me.
No, I'm not familiar with that one. Oh, yeah. Sorry. Yes, the documentary concave.
Yeah. Concave. Everyone, the Bilu.
But didn't FE Core do a 40-kilometre laser test as well?
that was Balaton, wasn't it?
Not sure.
I forget the distance. I think it might have been slightly more than that.
I think that was trouble with upward bend, the wrong way, wrong type of diffraction, wasn't it?
Yeah.
Was the biggest trouble with there, that the beams were going upwards, weren't they? Bending upward distance as opposed, but completely the wrong way. If you were going to generate a
apply the magic K,
yeah,
the magic K value. It's interesting you said that, Rob, because that's how I know it. Other people know it, but what was it, 7/6 or 6/7 or something? Adam, it's put on that
it's
debunk site.
7/6R for optics, but I think what Rob was referring to was there's a slightly different calculation when you're talking microwaves. What was it? What was the ratio?
K value, it's 4/3 or something.
4/3.
4/3R, yeah.
Well, I came across it in land surveying. I think I was looking into how their optics work with that thing they use. I can't remember what it's called now. It's getting late, but they were talking about adjusting for the K value, and it's 4/3 as well, and that was geodetic surveyors or whatever.
But you love that bullshit. The K value.
The K
to
value.
Like validate it. It makes it sound real. It's the K value. It's not. It's just an arbitrary number we've made up to excuse it bending round an earth when it's just flat, which is all it needs to do. But suddenly it bends. But we can't have quite the same bend as an optical bend because it's a slightly different kind of wave. So we'll have a slightly different ratio.
X value implies that we don't know what it is. So we just give it a bit of a kink and call it a K. It's a K value.
It's hilarious. And they call it the R value, don't they? On the debunk site.
It's 7/6 SAR, isn't it?
That's right, yeah. But do they call it something?
Is it terrestrial refraction? Is that what it is?
I think it's
standard.
standard. They call it standard refraction.
Standard, is it? Okay.
I had a little bit of a mathematical moment. Sorry. Basically, if you multiply the numbers out, they're very close. It's 21/18 or 24/18 for the 4/3.
Yeah.
But it's slightly more bend for the silly, isn't it?
For the debunk site or for the
standard, but standard.
Oh, right. So that applied slightly more bend, did it? Oh, there's no supply there. Yeah. There's no surprise there. That's the tiptoe, isn't it? Into their nonsense. Right. Well, this is getting on for a Christmas day to be all taking up people's time with our nonsense. Is it time to move it on, do you think? Is it time to cut the cord and get on with merriment?
Don't go cutting cords, savage. Don't go cutting cords. There's no need. I do think we've probably battered Rob enough and picked his brains enough on the stuff he's been up to, which is pretty damn awesome, fella.
Well, while we're recording anyway, I hope Rob will stick around for a bit more merriment afterwards. I want to get the lowdown, obviously.
He's going to sing the chicken song with us at the end.
Stick a deck chair up your nose.
I jump out, yeah. And then Barry, I'm not doing it. I'll do it at the end. I'll do it.
Yeah, you two got to sing that out at the end, because and I'll sing along because it's on the tip of my brain. Every lyric to it, I can't remember it, but now you just mentioned deck chair up your nose and chicken on the brain or something. I'm sure I'll sing along. Do you guys in the US know what the hell we're talking about?
Vaguely.
Not a clue.
Maybe, vaguely.
We'd get a strike, wouldn't we, if we played it?
My metal
Most likely.
detector's working.
Your what?
Metal detector's working again.
Hey, Cammy.
Hey, Cammy. Feel better.
Everybody's saying hi, Cammy.
Hi, everybody.
Tell her feel better. Try some golden milk. It's excellent when you feel bad.
You said golden milk.
That's also good.
Isn't there anyone who knows what Christmas is all about?
This is Jackson Brown wishing you a Merry Christmas and a Happy New Year.
The earth is flat.
I'm at one with the Yuletide, know what I mean?
All right. On that note, I think we should wrap up, and I think this has been an awesome hour and a half.
It has been amazing.
And a plus, a bonus for any one of those people that want to subscribe, hit that bell, do whatever, follow us on D Live. I've run out of shit to say.
I told you to goof it up.
Rob Durham's channel, the links will be in the description. It is still one of my go-tos, Rob. I probably told you that when you came here way back. Truly, the star videos, the horizon, different shapes, those videos, man, you were one of my go-tos back in the day. So it's great to have you on. And certainly let me make the invitation if we haven't. Josh and I and Zach also do a show on TFR. It's a little strange time frame, but we could probably work it out with you. So you're officially invited on Ironworks. Let us know when you have some time.
Okay, thanks guys. It's been fun. Thanks for having me on again. Hope to do it again soon.
No worries. Don't hang up. And TFR actually works perfectly for the UK. It's 10 a.m. in the morning. So
unless you're John Savage.
Thank you, John. I forgot. We're 10 a.m. Right. It's pretty easy.
Yeah, unless you're me. Which, yeah, I don't remember the last time I saw 10 a.m. But yeah, there you go. Nocturnalism.
Well, before we wrap up then, I suppose if it is, I think we're planning for Boxing Day. It could be Christmas Day. It could be this Friday. Who knows? Who knows? Because Josh is going to be watching Star Wars, so it could all go wrong.
We're all time traveling, mate.
Maybe a Christmas message from us all then.
Oh God!
We've got anything? Shall I start? Bow your heads then, dear Father. No, I'm really fagging. Yeah. No, I just want to wish anybody who's listening and all the flat earthers out there, it's been a mad year, an awesome year. I've had some highs, very highs when I got squeezed in Rome, and some lows. But again, I look forward to next year. God knows where it'll take us. The way I think this thing's going, it's been absolutely brilliant, and love to everyone. I look forward to next year. That's not really next year, but only from a Saturn-based point of view. God bless. Happy Christmas, everyone, and I'll see you next year.
You soppy bugger.
I know.
Who's next? I haven't thought of anything witty enough to say. Yeah, you're right.
Yeah, you should have went last, Adam. Just say ditto. No, this has been a great year. You're right. And gosh, I can't even imagine what next year is going to bring. The number, it had to have doubled in people who are openly speaking now about flat Earth. Just in this last year, it's been such a snowball. And yeah, I'm excited. I can't wait to see what happens in a few months when the new year starts. Love y'all.
Oh, that's lovely, Zach. I'm going to jump in and quickly say thank you to the chat. I do love you. I don't watch you, but I appreciate you there, and I wish everyone a happy Christmas, and here's to 2020, because there is no stopping this snowball. It's probably going to end horribly, but there's no stopping it. So happy Christmas, enjoy it while you can. You're all doomed.
That was not a John Savage Christmas greeting. I don't know what one would be. That was classic. Thank you, John.
Shit the bed, it is Christmas. He used the L word.
Now, how do you go after that? My goodness. Well, I'll just say it has been an amazing year. Thank you all. Chat, everyone who comes and hangs out with us over there in Ironworks in the morning, the Iron Scouts. We love you guys. Everybody who helps out in all the ways you do. Thank you all so much. You guys here that I've come to know and love, family, truly, brothers and new sister. Hope you feel better, Cammie, by Friday. Love you guys. Thank you all. Rob, love you too. Like I said, you've been a go-to since day one. So thank you as well. And have a great holiday, everybody.
Woohoo! Huh? So, straight from the bottom of my heart, I just want to wish everybody a happy Wednesday.
Just gave the game away.
From the bottom of his heart.
It's not Wednesday, it's Christmas.
Fantasy ruin. Christmas spoiling Grinch.
That was deep, man.
I mean, enjoy your presents. I hope you get everything that's super expensive and super high tech and that will track you and wipe your baby's butt and do all the stuff that you don't want to do yourself so that you get lazy.
Here we
and
go.
Stay inside. Yeah, I don't know. Merry Christmas. I hope it's great.
No, you carry on. Rant, man.
Happy New Year. The new year shall bring showers and then May flowers, I think is how that works, because we still got several months for the new year. So I'll get to that once the new year comes.
Yeah.
Yeah, it's only 3/4 of the way through the year, so stop banging on about the new year, people. March, God's sake.
Hold up. Rob Durham, have you got any profound message for humanity?
As the Vulcans would say, live long and prosper.
That was the best of luck.
Well, there's an out if ever we had one. Of course you're not. You're just a helicopter pilot who buys gyrocompasses and plays with balloons in his kitchen. Nothing wrong with that.
Okay, perhaps a little bit geeky.
Hello, everybody. This is William Shatner, and a Merry Christmas and a Happy New Year.
Hi, this is George Takei from Star Trek, wishing all beings on all planets a Merry Christmas and a Warp Speed New Year. Hi, this is Jonathan Frakes.
Oh, my.
Wishing the entire universe a happy holiday season.
And if I'm going to tell you one thing, I'm going to tell you this. Have a safe and happy New Year and Christmas, but don't drink and drive. Do one or the other.
See, do you know, Rob, how happy you've made? Josh had no idea how he was going to get that button link in, and you just gifted him. That was your Christmas gift to Josh, I think it was.
I think we had didn't we have something from Stephen Hawking? He wanted to
Oh, Stephen got a message for us.
I have a premonition. Oh, Steve's got a premonition. Well, Stephen said that he foresees a copyright strike in our future.
Oh, that was beautiful.
You can try and cover up the depth of that message, Savage, if you want, but I think both me and Walt know what he said there. And I felt we Walt. What about you, mate? Yeah, that was special.
And enjoy your Wednesday.
It won't last.
Right then.
So we got a little
Okay.
music to go out on, and
Right,
I guess we'll wrap it up and be done.
We struggled to get a tune to come in on, so help us on the way out, Josh.
Not Slade, not Band-Aid, not George Michael, not anything I would hear in a shop on Oxford Street, please.
Do we not want the chicken song?
Oh, you two were going to sing it, Rob. Don't you slink off yet, and don't hang up either way.
Right. Rob's having internet issues.
Yeah, I think you better play whatever you can play and get us the hell out of here. Good, happy Christmas, people.
What's the matter with misfits? That's where we fit in. Different from the best.